DHCP, surprisingly, was a relative latecomer on the internet. Now, every computer on the internet has to have a unique IP address, and that was all done manually for the longest time. It wasn't too bad when there were just big mainframes on the internet, but later on in the early 1990s and so forth, when companies with hundreds or thousands of computers that all wanted to be on the internet came along, we needed an automated way to hand out those IP addresses, and DHCP, or Dynamic Host Control Protocol, was born. DHCP operates off of a server, and that server will provide clients with its IP address, the DNS server addresses, the default gateway, which is the address of the network node on the nearest router, and then, in other words, the router that network is connected to, and a lease time. Now, the DHCP server typically has to be on the same IP subnet as the clients it serves. It can't really hand out an IP address to a computer on another network because that's not under that DHCP server's control. You can use something called a DHCP forwarder, but that's beyond the scope of the discussion we're going to have right now. The process by which a client goes through in order to get an IP address from a DHCP server looks like this. First, there's a discover packet that's sent out, and in this, the client sends a broadcast asking for a DHCP server to respond. So it just sends a broadcast address out and says, hey, are there any DHCP servers out there? Now the DHCP servers return an offer. There might be 3 DHCP servers, and they all return an offer saying, hey, yeah, I'm a DHCP server, I can help you out with that. Now the client, in turn, makes a request and chooses one of the DHCP servers, usually the first one that responded back. And then finally, the acknowledge is when that DHCP server finally sends the information, the IP address and default gateway and DNS server information and lease information all back to that client. We know that process as DORA, D-O-R-A. IP version 6 has a similar process, but it doesn't have broadcasts. So we use something called an anycast address, which means, hey, the nearest DHCP server out there, please respond. As far as the lease goes, now when a client detects that the lease time is halfway completed, halfway expired, it will request a new DHCP extension of the IP address, and the DHCP server will typically then issue the same IP address for another lease period, although it can give a new one if it needs to for some reason. And here is the ipconfig/all command on my Windows machine, and you can see here that the DHCP server has given out the 10.0.0.103 address to this computer, subnet mask 255.255.255.0. Here's the lease date and then the lease expiration date. Now when it gets halfway between this date and this date, my computer will ask for a new one and the DHCP server will send out a new one. Here's the default gateway, so my router that this particular computer is connected to, the node on that router that's connected to is 10.0.0.1. Notice they're on the same network here. And then the DNS servers, well, notice this is not on the 10 network. The DNS servers can be off of the network, and these indeed are the DNS servers at my internet service provider that I go to when I need to resolve a name to an IP address in order to send a packet out over the internet.